In section 7.2, we're going to consider trigonometric integrals, or trig integrals for short. So the first type of integral we're going to consider is powers of sines and cosines, so where at least one of m and n is an integer, maybe both of them. And the first case we'll consider is when we've got an odd power here on the cosine x. So if that's the case, then what you're going to do is you're going to split off one factor of that cosine x, and that's going to be part of your du. You're going to use the identity cosine squared is 1 minus sine squared to write all the other cosines in terms of sine x, and then use a u substitution, u equals sine x. So let me demonstrate this. So we're going to integrate cosine cubed. So I see odd power on cosine, so I'm going to break that up to be cosine squared x times cosine of x dx. And the cosine x dx, the odd power that's left over, or the one cosine that's left over from the odd power, that's going to be my du. And my u is going to be sine x, so I have to write that cosine squared in terms of sine squared. So I can write cosine squared is 1 minus sine squared x, and then times my cosine x dx. And now u is going to equal sine x, and my du is going to be cosine x dx. So this will be here, this will be 1 minus u squared, and then cosine x dx, there's my du. So this is now integral 1 minus u squared du with that substitution. And that's definitely an easier integral. This is just power rule, right? So antiderivative of 1 is u. Antiderivative of u squared is u cubed over 3, or 1/3 u cubed, and then plus a constant. And now we just have to reverse the substitution. U is sine x, so this will be sine x minus 1/3, and then u cubed will be sine cubed x. And then indefinite integrals, so plus the constant on the end. And that's all there is to it.